Inorganic chemistry, p block elements. Group 15. The members of this group are nitrogen, phosphorus, arsenic, antimony and bismuth. Nitrogen is the diatomic gas and has a very low boiling point due to very intermolecular force of low intermolecular force of attraction. Nitrogen itself is triply bonded, but its molecules are not strongly bonded with each other, and hence its boiling point is very low. Phosphorus exists mostly in the tetrahedral, that is in the cages form. Arsenic exists as extended sheets of AS atom covalently bonded together. Antimony also has a linear covalent structure. Bismuth has a metallic bonding and its melting point is lower than that of arsenic and antimony. Nitrogen is very unreactive as because of its triply bonded atom. Nitrogen can be fixed industrially by the Haber process, in which nitrogen reacts with hydrogen to produce ammonia. Hydrides of the other group members are formed by the reaction in water of the acids in a metal phosphide, arsenide, stibine, bismuthine, etc. Ca3P2, that means calcium phosphide, hydrolyzed to produce the phosphine in these reactions. Similarly, we can produce arsine, bismuthine, stibine, all the MH3 type of hydrides. Halides are generally of EX3 types, only nitrogen that cannot form that trihalides in that way, but this EX5 is also produced excepting nitrogen and bismuth. Bismuth cannot form as because of the inert pair effect, whereas nitrogen cannot form because of the non-availability of its d orbital. Oxoacids are generally formed by this group 15 elements. Oxoacids are basically those acids which furnishes proton. That proton is bonded to the central atom via oxygen. All the EX3 and EX5 type of halides undergo hydrolysis producing the oxoacids, and again that EX3 type of hydrolysis is not possible with the nitrogen, whereas the EX5 are not possible with the nitrogen and bismuth. Two allotropes of the phosphorus, the white phosphorus, which is tetrahedrally discrete molecule, whereas the red phosphorus is a chain structure in which the units are interbonded, and that makes a difference in their reactivity, as a bond strain is there, huge strain inside because of this discrete and crowding of this bonded electron, and hence white phosphorus is relatively more reactive than the red phosphorus. Patterns of behavior of the group 5A, in case of that nitrogen, the 3 electrons to form the azide ion, but it is only possible with the compounds interactive metals. Higher element of this group metallic and the loose electrons to form the cations. Oxides changes from acidic to amphoteric as the metallic character increases down the group, so that is conventionally the oxide natures follows the same order. Oxides of nitrogen. Though nitrogen is typically very non-reactive, but nitrogen forms a series of oxides only because of the symmetry in their orbital configurations with the nitrogen and oxygen. So easy overlapping results formation of this series of oxides. These are the different oxides in a comprehensive table where you can easily visualize that nitrogen forms the oxides and their basic structure. One important observation with the nitrogen oxide that the NO2, which is the nitrogen dioxide, does not exist as this molecule, it exists as a dimer only because of the odd electron on the nitrogen atom results formation of this dimerization. Oxoanions of the nitrogen. Nitric acid is produced by the Oswald process, of which the formation of nitric acid involves nitrogen dioxides and then subsequent hydrolysis to produce this HNO3. Nitric acid is very strong oxidizing agent and it produces the nitrate ion when undergo ionization. Nitrous acid is typically weak and then it's unstable, so therefore it cannot be preserved as nitric acid is. These are the basically oxoacids of the nitrogen, of which nitric acid and nitrous acids are of importance. Nitric acid on ionization produces nitrate and nitrous acid on ionization produces nitrite ion. Important oxides of the phosphorus, that is P2O5 and P2O3. Actually this remains in the dimer only as it can form cages, It is unlike to the oxides of the nitrogen where no cage and clusters are available, but phosphorus can form this type of cages. Oxoacids of phosphorus. Like nitrogen, phosphorus also produces these oxoacids, of which this oxoacids that basicity depends upon that number of proton which is actually bonded to the central atom via oxygen. These are actually available for the deprotonation. So in that case, that H3PO3, that will give in that structure H3PO3, it will give you only 2 proton under hydrolysis, and that's why the basicity is counted as 2. Whereas in H3PO4, it is very much imperative that as all the 3 H atoms are bonded to the central atom via oxygen, so these oxoacids will typically produce as 3 H plus ion under deprotonation, and its basicity counted as 3. Group 16 elements. Basic members are oxygen, sulfur, selenium, tellurium and polonium. Oxygen, like nitrogen, occurs as a low boiling diatomic gas. Sulfur, like phosphorus, occurs as a polyatomic molecular solid. Selenium, like arsenic, it commonly occurs as a gray metalloids. Tellurium, like antimony, displays network of covalent bonding. Polonium, like bismuth, has a metallic character and it is somewhat radioactive is also nature. Halides are formed by the direct combination, like EX2 type, unlike that group 15, they produces EX3 and EX5, they produces EX2 type of halides. The thiosulfate is also a natural phenomenon. The sulfur, when boiled with Na2SO3, it produces thiosulfate. Allotropes of the oxygen family. Oxygen has 2 allotrope, O2 which is essential to life and O3 which is ozone, which is poisonous. Sulfur has more than 10 different forms due to the ability of the S to catenate. SS bond lengths and bonds angles vary greatly. Selenium and several isotopes, some consisting of the crown shape Se8 molecules, and show some abnormal molecular masses. Hydrides of the oxygen family. Oxygen forms 2 hydrides, H2O2 and H2O. These hydrides of the other group 16 elements are foul smelling and poisonous gases. H2 and H2O2 can form H bonds and therefore have higher melting and boiling point than other H2E type of compound. Hydrides bond angle decreases and bond length increases down the group as the intermolecular as the bond between the atoms lengthens and their repulsion decreases. Hydrides of the oxygen family. Except oxygen, all the group 16 elements form a wide range of halides. Their structure and reactivity pattern depends on the size of the central atom and surrounding halogens. As the central atom becomes larger, the halide becomes more and more stable. Sulfur forms 2 important oxides, SO2 and SO3. Sulfur forms 2 important oxoacids also, H2SO3 and H2SO4. Thank you.